let's see what are the implications of the protocol type. The protocol, as you know, is a set of rules that should be followed or that will always be followed. But it is usually not complete, and the protocols assume that everyone is trying to play by the rules. What if they don't play by the rules? There are specific attacks against specific protocols. Vulnerabilities in port 80, HTTP protocol, in SSL, in SSH. So there are vulnerabilities or specific attacks against specific protocols. There are several threats to network. Some of them have been discussed here. Wiretapping is one. Impersonation. Attacks on the messages which affect the confidentiality and integrity. And denial of service attack. If you see here, all of confidentiality, integrity and availability are, or loss of confidentiality, integrity, availability affect the network. In wiretapping, there are two kinds, passive and active. What is passive? Passive is listening in illicitly on conversation, like your traditional wiretapping on the telephone lines. And active wiretapping is injecting traffic illegally or illicitly within the network. Packet sniffers can listen to all traffic on a broadcast medium, either on Ethernet or on 8.2.1, which is a wireless. Now, an example of packet sniffers is Wireshark, which is the most popular one. Then, wiretapping on wireless also often is just a matter of putting up an antenna. What happens is there have been several instances where people with a powerful antenna connected to the laptop drive around places where wireless network is available, try to hack into the wireless network using tools like Kismet, and then try to get into the network. A simple explanation of an impersonation is a packet comes in over the network with some kind of source indicated in the header. Now, the action to be taken with the packet depends on the source. What is to be done with that packet? But attackers may be able to create packets with false sources. Now, packet is nothing but your data is broken down into pieces with adding certain information, and the packets at the destination are reassembled to give you the actual message. So attackers may be able to create packet with a false source, indicating that it is not coming from the original intended or original location. How is the confidentiality of message violated? There are problems that can cause message to be inappropriately divulged. Misdelivery or non-delivery. Both can be an issue. Here, misdelivery can send a message to the wrong place. So, clever attackers can make it happen. Message can be read at an intermediate gateway or a router. Sometimes an intruder can get useful information just by traffic analysis by using tools like Wireshark. He may be able to know the pattern of traffic that is going there, what kind of messages are going there, what actually is going back and forth in the network. How is integrity affected? Even when the attacker cannot create packet that he wants, sometimes he can alter the proper packets. That means your veracity of the data being transmitted is affected. While to change the effect of what the packet will do, and also it requires access to the part of the path that the message takes. So the attacker will require the part of the path that message takes to affect the integrity of messages being transmitted. Perhaps the most common attacks on networks is the denial of service. They are attacks that prevent your authorized users from doing their work. It can be caused by flooding the network, by sending in a lot of requests to the server so that they can't handle it anymore, or corrupting the routing tables, or flooding the routers itself by sending in a large number of packets, or even destroying key packets on the way to its destination. So all these can cause a denial of service attack. So how does this denial of service attack happen? Basically, the attacker injects some form of traffic. Nowadays, the networks aren't built to throttle uncooperative parties very well. So, and the all-inclusive nature of the internet makes basic access trivial because you know that the common protocol uses TCP/IP. So the first step is already there. And then universality of the IP makes reaching most of the network easy. Again, like I said, since IP is the most common or preferred mode of communication, reaching most network is pretty simple. Now, let's see an example of a Synflood. It's based on the vulnerability in TCP, that is Transmission Control Protocol. The attacker uses initial request response to start the TCP session to fill a table at a server. What it basically does, it prevents a new real TCP session. Syn cookies and firewalls with massive tables are the possible defenses. Let's see graphically what exactly happens in a Synflood. In a normal Syn behavior, the client on the left sends a Syn packet to the server. The server acknowledges with the Syn ACK packet, and the client responds with the ACK packet. So Syn, ACK, and ACK. This is basically the TCP three-way handshake. So this is how a normal Syn behavior will work. Now let's see how a Syn flood will happen. The attacker sends a Syn, the server responds with the Syn ACK, the attacker again responds with the Syn, that's a double one on top, and then from somewhere else, the attacker sends another Syn, so the server cannot actually fill that request. So what basically happens is, the server gets flooded with the request. So a Syn flood happens. General network denial of service attacks, it may not tickle any particular vulnerability. Meaning denial of service attacks may not tickle any particular vulnerability. It can happen to any system. It can achieve success by a mere volume of packets. If more packets are sent than that can be handled by the target, then the service is denied. It's a hard problem to solve. And DDoS, or distributed denial of service attacks, the main goal is to prevent the network site from doing its normal business. The method is overwhelm the site with attack traffic from different sources, from distributed sources. What is the response? Again, the server will not be able to process that information and a denial of service attack will happen. This is an example of a denial of service attack. The problem is there are several computers coming in or attacking the server from several sources, different geographical locations, not necessarily within the network. So then it inundates the network of the server with so much of traffic that the server cannot respond and a denial of service or distributed denial of service condition occurs. So why do people do this attack? Why are these attacks made? Generally to annoy. It sounds rather silly, but that is a cause for this. Sometimes for extortion, sometimes to prevent adversary from doing something important. If it is directed at infrastructure, it might cripple parts of internet also. Say for example, if it is directed at an e-commerce site, a popular e-commerce site like eBay or Amazon or Flipkart, then it might cripple parts of internet. Or if it is a banking site, it may again cripple parts of the internet. So the attacks are made for generally to annoy, just to bring down the network, fun of it, ego. Then for extortion. So if you don't pay me money, I'll keep bringing down your network. To prevent the adversary from doing something important, maybe two parties, different parties, are applying for a tender, which is very important, and one of them has the capability for doing a DOS attack. He tries to prevent the other person from submitting the tender by creating a DOS attack on his network. That could be an example. There are different methods for this attack. One is pure flooding of network connection, pure flooding of upstream network, or overwhelm some other resources like eat up your CPU resources, eat up the memory, cause a Synflood to happen, or eat up application level resources. It could be any of the method that can be used. It can be a direct DOS or a reflected DOS. But why distributed attacks? Because targets are often highly provisioned servers. So nowadays the computers or the servers which handle these sites are highly efficient with tremendous processing powers, tremendous memory, and a large storage space. So you need to have a distributed attack because one or two systems on the internet will not cause a server to come down. That's what the next sentence is. A single machine usually cannot overwhelm such a server. So you need multiple machines to do so. So it could be that each of the computer identified by the hacker could be a zombie or it could be a part of the botnet. So then all of this do a concerted attack on the server. But then it makes the defense also harder because you don't know where actually the traffic is coming from. It comes from everywhere. So how do you defend these kind of incidences? One is you can't just stop a flood. You have to just ensure that the services to legitimate or authorized clients are given. If you deliver a manageable amount of garbage, you haven't solved the problem. That means you can't give information in piecemeals. The information that is available to the authorized users should be legitimate. It should be in full, in toto. Nor have you, if you prevent a flood by dropping all packets. So if you are going to drop all packets, then no, even the authorized packets will be dropped. It is of no use for the authorized users. There are complicating factors to this. It's the high availability of the compromised machines. That is, there are millions of zombie machines out there which are a part of your botnet. Internet is designed to deliver traffic regardless of its value. So you take a small informative site to a site hosted for a bank, to an internet banking site, to an e-commerce site. So everything goes through the internet. Regardless of value, internet banking will be valued much higher because your financial transactions are happening. A static site will be valued lower because of the static contents or the informative contents, which is anyway meant for general public consumption. Then IP spoofing allows easy hiding. Spoofing is you are actually the IP spoofing is you enter a source address in your header for the purpose of masquerading or hiding your real IP, so that the source of the packet will not be known. Then the distributed nature makes legal approaches hard. Now, if there is some hack coming in from a foreign country, how do you take action against the perpetrators? It becomes a legal issue also. Unless there is a cooperating agreement between the two countries, it can't be done. Then attackers can choose all aspects of his attack packets. That means a lot of packet can be like a good packet with no visible differences, so that it becomes very difficult to identify which is a false packet and which is a true packet. Some of the basic defense approaches are over provisioning, which is not actually a good idea. Dynamic increase in provisioning, so as and when the server requires, it takes the resources. Then hiding, tracking the attackers, taking legal approaches, reduce volume of attack by putting some kind of filters, but none of these are totally effective. But there are traffic controls mechanisms like filtering, where the source address filtering can happen. So if my packet does not come from the source, drop it. Other forms of filtering are there. Then limits on rates of transmission that can happen. Protection against traffic analysis or traffic padding. We will discuss about traffic padding. Then routing control is there. So padding actually involves having or sending a lot of packets, encrypted packets, along with your genuine traffic, so that it becomes difficult for anyone to identify where the traffic is coming in. So if there are a lot of encrypted traffic going, By you doing traffic padding, a continuous stream of encrypted padding also goes in the network. So if there is an attacker sitting somewhere and if he is trying to decode the traffic analysis or he is trying to get the analysis or pattern, it becomes difficult for him to find out because a lot of useless encrypted data is also sent in the network. So analysis of the traffic itself becomes very difficult. Then there is source address filtering. It is basically filtering out some packets because of their source address value, like I said before. So if you say that the network should not accept packets from this range to this range, drop the packet. Usually because you believe that their source address is spoofed. It is often called ingress filtering. There is also egress filtering where you can prevent the destination address filtering from your network. Source address filtering is basically used for address assurance. That is, router knows what network it sits in front of. In particular, it knows the IP addresses of machine that it is interacting with. It filters outgoing packets with the source address not in that range. So it filters outgoing packets that filtered which is not in the range set in the router. And it prevents the users from spoofing other node addresses. But within the network, the clients can spoof each other's addresses. That is possible. This is a simple example of source address filtering. Now, my network shouldn't be creating packet with this source address. The source address here is 128.171.1.2, which is not there in the address filtering. So drop the packet. It's a very simple example of how the source address filtering happens. The outbound is called egress, or ingresses that comes in. So it occurs as packets leave the internet and enter a border router. So from both sides, we are looking at both sides. One is egress, the packets going out of the network and going into another network. Now, it occurs as the packets leave the internet and enter a border or edge router on the way to that new router's network. Now, it determines what address shouldn't be coming into your local network. So, egress is you send the packets out. The router at other end does an ingress filtering, determines whether this packet can come in. If it is not in that list, it drops the packet. An example of this is filter incoming packet. Packet with this address should be going out. It should not be coming in. So you drop the packet. So it's a simple example of how the incoming packets are filtered. So a particular source address is there. Now in the network, it is configured that these packets should be going out and not coming in. Since it is coming in, it drops the packet. There are other forms of filtering. That is, you can filter on things other than the source address, such as worm signatures, unknown protocol identifiers, and so many other things. So, if there is a worm that is coming in, you can filter based on the type of worm that is coming in. So you can say basically the rules will say anything in the database which resembles in the worm database which we have. If any packet resembles that of a worm signature, drop it. Also, there are unallocated IP addresses in the IPv4 space, which is now the IPv6 is coming into O. So it can filter for packets going to or coming from these addresses, the unallocated addresses. Then some source addresses may be used for local use only. So internet routers can drop packets to them or from them. Now when you talk about networks also, you need to understand what is a class A network, class B network, class C network, what is a loopback address. So you can write it down. Go to the internet. It is a part of your CCNA basics. So you can actually go to Google, find out what is a class A, class B, class C network, loopback address, what is ARP, what is RARP, what are the different protocols used in networking. So you can learn about that. But you should have realistic limit on filtering also. Little filtering is possible in the internet. The internet is meant to be a repository of information sharing. So you can't filter everything on the internet. And the packets go back and forth very fast. And your backbone providers, maybe your service providers, don't want to filter for obvious reasons. Unless there is a regulatory requirement that this site should be blocked, they don't generally block. Now, if the filtering is not done properly, damage will be great. So that is another issue. And filtering near the edges, that is the border or perimeter of your network, also has its own limits in what is possible, what is affordable, and what the router owners also will do. You can't put abundance of protection in the network or on the perimeter of the network, which is highly unaffordable to you.